Okay, thank you very much for joining us to see discuss what we are doing and the future and the plan. You can also turn on the captions on Zoom, so if my poor English is not clear. So about the current status, so far we have on the marketplace for the VS Code editor, we have around 10,000 installation, and then for the Open Basic, we have around like the 90,000 installation. And on our package manager, mooncakes.io, is close to 3,000 packages for language. We only have been open for 2 years. I think it's a good number. This is the current status. And the really exciting thing I want to share with you is the MoonBit AI. Actually, we achieved a lot of the really great progress in the last few months. The first one is the models. So of course, for the AI, for the code generation, the model plays a key role here. So we noticed for latest model from the top tech companies like the OpenAI, so the GPT 5.2 and the Cloud Sonic 4.5 and the Opus 4.5, they are very good. Actually, very good at generating movie code, especially when you are using our system prompt. So our system prompt is open source, so you can basically generate thousands of line valid MoonBit code in one go. So actually, I use the codecs and both codecs and Sonnet 4.5 daily work. Actually, I didn't notice anything different from the other mainstream language. So it's really good. Actually, I want to share with you. So my common workflow is I open my uh, suppose let me ask. So my common workflow is I will open a virtual box. For example, here is my system prompt. Oh, here's a I turn my phone. Anyway, so my common workflow is I open my VirtualBox machine and then I will start I code. Here I copy here is a yeah, this is my common workflow. I have a clean repo and I have a reference. For example, I'm going to implement a scheme interpreted in MoonBit, right? So I will have a reference implementation and I have my agents.md, agents.md. Then I will start my codex, basic codex, and say, I'm going to, let me make it a bit large. I'm going to implement a scheme in MoonBit. And then I will say, okay, reference OCaml scheme con, contains a reference implementation and our agents.md file has the information relevant to MoonBit. Please help me finish this project. Then the AI will study to write a lot of code in MoonBit. And actually, I found it has a very high successful rate. Basically, you just wait for like the 1 hour, or if it's good, maybe half an hour, then everything is done. Perfect for you. So, so it means actually the large language model has a very good understanding of MoonBit. So for example, we are going to open source like the WebAssembly virtual machine implemented in MoonBit. It's mostly like AI generated code. We have some reference implementation and we have a lot of spec tests. Then here we go. Then the AI will do all the work for you in one shot. Actually, basically, if you are lucky, you don't need to do any debugging. You just pass all the tests. So that's really very cool. Because why is I'm so excited about it? Because for new language, the most challenging question is is a new language, right? You don't have a rich ecosystem. They need a lot of libraries. Then this solves the problem, in my opinion. We will use a scale use the AI at a scale to help you generate all the libraries for you. This is something I'm really excited about. So so you can give it a try. Of course, you have to use the latest models, the GPT 5.2 and the Cloud Sonic 4.5. They are the only two models I think works really well with MoonBit. Hopefully, in half a year, then we have more open source projects on GitHub, right? So now all other large language model will catch up. So we will help us unlock the AI to boost the MoonBit ecosystem. This is one thing I am really excited about, and I'm very happy to share with you. The other is we open sourced a library called Codex SDK. It's basically a wrapper on top of the OpenAI Codex. So OpenAI Codex is written in Rust. For the official repo, it provides the I believe is a TypeScript and Python bindings. So we also provide a codex bindings for the OpenAI codex. So it means you can use the MoonBit to write the glue script to do the all the AI code generation. And this day there's a new concept called skills. I think skills will be a very shiny place for MoonBit because skills is basically for people who don't know skills. Skills is basically a markdown file and with some scripts to help AI to learn the skills and do the code generation. But MoonBit, because we compile the WebAssembly, right? And it's portable. So you don't need to, if you are going to distribute the code, for example, in Python, then you have to ask the user to have a Python runtime, Python installation for them. But this is not the case for MoonBit. We can basically have some markdown file with MoonBit, and then we compile the MoonBit code in the WebAssembly. Then we have a portable MoonBit skills for the AI to do the like PDF generation, a lot of cool stuff. So I'm really so exciting to make MoonBit a shiny place in the skills. Oh, another thing we are working on is a Mario. It's an agent. It's a agent framework written in MoonBit. Previously, we have a called MoonPilot, the agent framework which was written in TypeScript. And then after we shipped the async runtime support, we finished rewriting all the stuff in TypeScript and moved into MoonBit, which is more static type language. And more than that, actually, we are going to ship 3 tools. One is the agent CLI. This is just like the codex you see. So it's basically a command line tools. And we also we are going to ship the agent code plugin. So we already published on the, I believe, we already published it on the marketplace, but it's still in the early days. For example, let me check. Actually, it's in here. You can have if you install the MoonBit, you search the MoonBit, then we'll have a uh, then you have a MoonBit. I think yeah. Oh, MoonBit agent. So this we're not public advocating it, but we are going to make it available to everyone. And we have a MoonBit here panel. And the cool thing you can because it's in the VS Code, you can just type hash and you can reference all the symbols in your project. Yeah. This is not a MoonBit repo, but if you are in the let me check. If you are in the core repo, right? You can like a hash and have all the symbols. And we also have some built-in functionality like the fix all warnings in parallel style. Yeah, that's the so for the Mario agent. Actually, we are going to ship 3 things. One is the agent CLI command line utilities, and then agent VS Code plugin, and we also have going to ship a agent GUI. So it's like a ChatGPT UI because you suppose you are going to have like the tens of the agents running in parallel. You need a dashboard. I need a place to like a centralized place to monitor all your agents, right? So actually we are going to ship 3 tools. One is agent command line, agent VS Code plugin, and agent GUI, and it's in full open source. And the good thing after we rewritten the TypeScript port to MoonBit is more solid because MoonBit is a static type language and it generates very small binaries, only like the 6.7 megabytes compared with the Rust, which was using by the OpenAI, which is I believe is 23 megabytes. So actually MoonBit actually generates even smaller binary size compared with Rust. So yeah, so this is already open source. We didn't public advocate it, but we are going to make it more stable in the next few months. And another cool stuff I'm going to share with you is the agent-oriented dev tools. So in a few weeks, we have like the it's already available in your distribution. You can run Moondoc, right? You have Moondoc. Let me share with you. For example, let me go to the core repo. I think you can say Moondoc the string split is already there. Command line, so you have so it will help you the AI to navigate the code base. So more than that, actually we are going to have the Moon IDE peak depth. Let me show you peak depth symbol. I think I'm not sure is a public variable or not. Okay, so yeah, actually it's here. So I was going to provide all the semantic-based ID functionality to the AI. So the AI can pick def your symbols. AI can outline your package, right? They will save you a lot of token because otherwise you have to read all the files in the package. And we also are going to provide AI, the Moon ID, the final reference. So AI will be exposed to these tools. So we help AI to write understand the code in a more efficient and reliable way. So I'm very, very excited about this. Yeah, and another cool stuff I think is I'm very excited is for the AI, also for AI, is for spec-driven development. So spec-driven is very popular in the AI these days because you write down your plan and then you ask AI to finish your plan, right? But the problem with the kind of the spec-driven is that the plan is an informal style. The plan is an informal style because you just make down files. So there's no way to type check your plans. So here, in MoonBit, we have a new feature called declaration. You declare your type, which is just declaration, just placeholder. Yeah, here I declare my type JSON, right? I don't do anything. I have no idea what the JSON type it is. Then, and I have no idea what the JSON path it is. Just declare type declarations, and then we have and I can based on the type declarations, I can write the test based on the type declarations. This is very similar to the functor in OCaml, but it's much more lightweight. And then with all the formal spec, I can ask AI to generate the code for me. And the good thing with this is the spec.mt. The spec is totally immutable. So the AI cannot change the spec because the AI can fill all the implementation in other files. So I just let me show you a real world example. Let me show you the real world example is here. So now currently I want to write a C parser, C standard compile parser in MoonBit, right? So if you see here, so I just co-designed with AI to develop a formal spec. The formal spec, the informal part is a markdown file. Okay, this is that's a spec. Or you want to write C plus parser, you have a Lexa parser, diagnostic conformance, right? And then you declare a formal types here. Here we declare the type kind, token kind, and the different error message. And here we just declare a translation unit. So it's a placeholder. Then AI will try to finish this in separate files. Here we have another declaration expression because it's going to be very big. We can just we co-design a very short formal spec, and then we ask AI to fill all the steps. Here is another placeholder. Let's note these are all warnings. There's no real world errors because everything type check. We have another declaration which is a path translation unit. So you see, we have all the. Then we can based on this type declarations, you can have a test. You can write a formal spec test. Here we have an easy test, and we have a difficult test, which is basically pass your C programmers. And then the cool thing with this is everything is formally checked. It is formally verifiable. I can go to the, for example, I can go to the C parser, go to declare, and I can, if you see my keyboard, actually I can run a moon check here. Okay, so you see, actually the compiler just give you warnings. The warning is because there are some placeholder which is not filled. The cool thing is I can just spec implement .mbt, and then I can just say, oh, this is a missed. I can just copy I can finish the implementation in a separate file and say, okay, remember empty array, right? Then the warning will be gone because you finished the missing implementation. And the cool thing with you can separate your spec from the implementation. So the spec is totally immutable. You don't need to touch your spec anymore. The thing why is important because AI often Like when AI cannot finish the spec, we will try to remove your test. Then with this, we can just make the our specification immutable. So AI cannot just try to remove your test and fake to say, oh, I finished the project. So this is something I'm really excited. We're currently using the declaration attributes, but we are going to make it a first class. Just use a declare and make it available to the all users. So we can use a formal spec-driven development. Okay, and another thing we are going on, we also have a because in AI engineering, the code review is really important. So we develop our own native AI based review tools. So our own diff tools with our own diff, we understand the semantics of the AST and the semantics of our tokens to give you a more precise understanding of what's the diff. So if you are going to only if you are only going to make a change to the format, you are only going to make change to the comments, then it will be totally ignored by our native AI review tools. So this is our progress in AI. We spent a lot of work effort to make sure MoonBit is a very AI native, so the AI can use all the tools to generate the MoonBit code in an effective way. And I believe this already pay off. This already pay off. So yes, yeah. Another thing I'm very excited because we have already very AI friendly tool chain. So we are going to open source our own WebSemi virtual machine, which was written in MoonBit next week. So we're planning to mix. Let me check if there is a message. Yeah, if you have any question, we are free to ask at any time. Feel free to interrupt me. Just make sure my message is well received. Yeah, you're welcome to interrupt me. So we are basically because all the code are generated. We have a lot of code which now is generated by AI. So actually, the one project, the Web Serving Virtual Machine, it have a lot of spec test, and it's totally complete developed in MoonBit with the help from AI. Yeah, this is something we are going to share with you. And because we are moving step by step to 1.0, we have some breaking changes in the coming weeks. The first, I think we are going to do the migration is we are going to migrate the internal iterator to external iterator. Previously, our iterator is an internal iterator. It's very similar to the Go, but it's unlike the C Sharp, unlike Java. So it's an internal iterator. We found some problem with the old design because the internal iterator doesn't really work with the async. So and it's not it adds a lot of complexity. So I'm going to migrate from the internal iterator to external iterator. So you are going to migrate the iter, which is the internal iterator, to the iterator type, which is the external iterator. Let me check if any message. Yeah, yeah, it's similar to the virtual package, but it's more lightweight because you can, yeah, you can have a partial, yeah, yeah, you're right. It's very close to the virtual package, but it's more lightweight because in your when you are writing your libraries, so you can just leave some of the function as a sub. Then AI will try to figure out how to fill the code. Yeah. So let's move back to the migration. We are going to, and this is backwards compatible. You can just implement your external iterator and then implement your own internal iterator based on the external iterator. Then it will be a smooth migration. And because of this, we can support the async iterator in the next few weeks. And even better, in MoonBit, the async iterator will be very similar to the uh, synchronous iterator because in MoonBit there's no await, right? There's no wait. So you can basically write the for x in read lines, but in the same style as with the synchronous. So actually the our async iterator will be very similar to the uh, async iterator. Unlike other language, for example, if you are using JavaScript, maybe you need a for wait x. Uh, I'm not sure. I'm not a JavaScript expert, but I guess you need something like this. But in MoonBit, just write the same style for everything in read lines. And another migration we're going to have is we're going to move away from the moon.pkg.json to moon.pkg. A lot of people complain because the JSON file doesn't allow comments, doesn't allow the trailing comma. Let me check the. Uh, Actually, I'm not sure. Our async iterator is purely MoonBit. So basically, it's basically async iterator. You basically have a function async. It's something like this. Async the async. Our async reader is very close to this kind of definition. And if you implement this protocol, then you can use the for X in the syntactic sugar. Yeah. Yeah. So another migration we're going to work on is from the moon.pkg.json to moon.pkg, but we'll maintain the backwards compatibility. So you can have the either moon.pkg.json or moon.pkg for a very long time. Then eventually we'll migrate away from the moon.pkg.json. This is coming very soon. Yeah, and for the our roadmap to 1.0 is still scheduled at the middle of the next year. So what's the lacking part is the async Windows support because currently async that only support the macOS and the Linux. So we are working hard to support async Windows. So it's almost finished. So we expect it will be the async Windows support will be coming in a few weeks, and after that, we'll try to bring async WebAssembly backend support. So you can also use the same async primitives in the WebAssembly backend. It's still work in progress, but the native side I think is mostly the finished. And another thing is Next Match is have been working on for a very long time, but we're going to migrate from the experimental. Yeah, let me check the magician. It seems like wrapping in Twitter would be fine. If async later automatic cycles through for it should be. Uh, I'm not really sure if I follow you. Uh, but basically, if your type has a like for example if your type have a for example if you have a like the you imagine you have a type right type T and you have type the fn T to iterator. Yeah, then you should be fine. So that's the anyway. So you can I guess you can wrap your JavaScript async to the movie one. That should be possible. Yeah, so let's get back to the roadmap. So after we see, and then we'll finish the next match. Actually, it's really cool. It makes your stream processing really nice. We are not only we are going to provide two versions of next match. One is for the maximal performance, so you'll be compared to a large code bloat, very large code bloat, and give you the best performance. Then we also have a provide a virtual machine based approach. For the virtual machine based approach, we'll compile much faster but slightly slower. So basically, we provide two versions. Let's match. One is the compile time expansion. Yeah, so no problem. For the next match, we have two versions. One is the compile time expansion, and then the other is a virtual machine approach. The second one is slower, but it's more compact and less code size. And actually, the last part I think is actually, its last part is quite important. We need to still to improve the core library, make sure that every type has a compatible API, core library takes, and then the last milestone, we want to match the async into the core library because we want to make sure people have the core standard library, then do a lot of useful things without install anything. Then we will go to the 1.0. Yeah, that's the our plan. If you have any question, I'm very happy to answer you. Uh, I'm very happy to answer take any uh, question. And then we have some we collect some offline questions. Yeah, there's some feel free to interrupt me if I have any questions. So yeah, so the first question I will collect from online is I'd actually like to know the roadmap for the making Python not yet open source. Uh, yeah, so the thing is, we open source a lot of stuff. I think 90%, almost like the 90% of the MoonBit project is open source, like the build system. The compiler is a bit tricky because it's not written in MoonBit itself. Okay, so let me just ask a question on are there any breakthroughs the plan for 1.0? Actually, just mentioned, right? I mentioned in the uh, here is a we are going to migrate away from the internal iterator to external iterator. I think these are two items I list here, and we have some like the there. I think from language point of view, everything I think mostly stable. But for the library, for the core library, they're still going to something. They're still going to change. Like for example, we plan to add a debug. We're going to add a derived debug for if you follow us closely, you will see we have a prototype here. Here we have a let me check. Uh, Here we have a public repo. If you see this debug prototype, here is the so we are going currently we have two ways to debug. One is using the to JSON. So you can derive the type to JSON and then insert value. This is very nice. Very happy. This is very cool. But there's a concept confusion. People think that to JSON and from JSON are the serialization format, but it's not really for debugging. But there's some very nice thing about the to JSON because you can do the snapshot testing and you can have some structural view. Actually, we are going to introduce a new type called debug. So you have the still you can do the pretty printing. You can have a structural overview, and you can also do the structural diffing. So this is another change, potential change we're going to have. Let me copy it here. So yeah, so we are going to have some backwards incompatible change, but these are mostly a library scope. So because designing a good library is really hard, we need a lot of the experience to try. And from language point of view, I think the change is very minimal. But for the library, we still have some change here. Sorry for that, but we need to make sure everything is right for the for standard library. Yeah, let me go back to the question. So, for the compiler, because kind of the MoonBit compiler is written in OCaml, it's like it's not really. We plan to make it publicly available when we finish the bootstrapping. We want to make sure everything we open source is in MoonBit. So, currently we already open source the front end in MoonBit. It's publicly available, but the backend is not. It's still written in OCaml. So. It will take a long while before we finish the full bootstrapping. But when we finish the bootstrapping from the OCaml to MoonBit, then we consider make it publicly available. Otherwise, if it's in OCaml, we don't think it will help us to gain contribution from the external. Yeah. So another question is regarding the breaking change before 1.0. Yeah, I agree with you. So we take 1.0 very seriously. Unlike the Swift language, right? If you are iOS developer, you know Swift. They basically break the backwards compatibility for every major version. That's something we don't really like to happen. So we want the 1.0 more like go long. So once you reach 1.0, you don't want to bring any backwards incompatible changes. So we take it very serious. So we totally agree with you. We don't plan to make any breaking changes after 1.0. Hopefully, yeah. So yeah, now the third question is when writing optimized code. Yeah, single shared performance is now on par with thank you. Now on par with C++. However, when writing a COI, there's no multi-thread, so it cannot be Go Rust in terms of parallelism. Are there any plan for multi-threading? Uh, So in the short, yes, I think you get the top point. So for our async, we use the similar model like the Node.js. It's an event loop. It's for the I/O operation. You can do the multi-threading, but for non-I/O for the CPU computation is not parallelizable. Of course, it's in our middle and long term, in 2 or 3 years. But to be honest, because for the you have to get the concurrency correct. It's not an easy task. So it's not going to happen before 1.0. So when we finish our 1.0, we will revisit this. Actually, because we have very ambitious goals. So after 1.0, I guess my approximation is maybe in the 2027. So that's a good approximation. So that's not going to happen in the near future. Oh, I'd like a worthy sandbox with, hey, congratulations. So we already have a web-serving virtual machine open source in the next week. So this is already finished for the worthy sandbox with the MoonBit. We will make it open source in a very MIT, maybe Apache 2 license. So you can contribute uh, official GitHub action. That's a good idea. I think we will provide some official GitHub actions. Yeah, I totally agree. Anthropic skills. So actually, we are going to provide the skills for the Anthropic compatible format. So yeah, we will provide this for you. Let me check another. I'm creating a collection of the bindings from the npm libraries that can be used with a JS backend called. Thank you. We will have a look. Thank you very much, Mijishi. If I'm not sure if I pronounce your name correct. Thank you, Mijishi. Yeah, uh, yeah, actually, I asked my colleagues to see if they can help, and we will also we are going to have some new interns. Maybe they can also help. Thank you very much to uh, help especially in the early days to help grow the MoonBit the ecosystem. Let me check if there are any questions. Okay, I think I basically answer all the questions online. If you have any uh, questions right now, I'm very happy to take and answer you. Uh, I cannot read the Japanese, but I will do the Google Translate later. Uh, Thank you very much. I will pause like for 1 or 2 minutes. If there's no questions,
Uh,
then we can stop here. Oh, okay, go ahead.
hi, Zank. A big fan of your work. Uh,
Thank you very much.
yeah, I've been following you since the Rescript days. So,
Oh,
mm,
okay.
yeah.
Yeah.
Very happy to work with Moonbit, and I had a great time working with it. Uh,
Thank
my
you.
right now, what I'm trying to do is I'm trying to do the native code in the VS
Mhm,
Code. But
mhm.
the problem is the VS Code extension doesn't detect properly the native bindings, the native async code properly.
Actually,
I-
yeah, yeah. Go ahead.
So, I mean, there's Swigglies for all the native moon checks. So, which is not actually a problem, but it shows it has a problem. So,
Yeah,
how do we
yeah.
work around that? So, that's my question for
I'm not.
today.
Yeah, I'm not sure if you are aware of. We have a configuration in the Moon.model JSON called a preferred targets. Like if you set the preferred targets native,
Uh-huh.
then it should be fine. But we
Yeah.
are going
Okay.
to, yeah, yes. So we are going to implement another feature called supported uh, targets in the library. So for example, in the future, for example, in the async library, because it only support native, right? We add a new field like supported targets native. Then when you compare in non-native, then give you a better error message. So yes, you remind me this actually a lot of people raise this question. I think we will prioritize this problem and give you a better error message in the future. Yeah, yeah. Thank you for your feedback. Thank you for your feedback.
Yeah, one other thing is like
Mhm.
I have like done like bunch of code. I will be open sourcing it. What is it now? It is touching close to 80-90,000 lines of code. So like what is it?
Oh,
Yeah,
yeah,
yeah.
of
It's
course.
and Moonbit is like working amazing level. What is it? Hands down. I had no problems so far. The problem is like I mean it's not exactly a problem, but if there are guides to find out the native performance more, what do you say, if there are MoonBit related tools to find out the crash
Yeah,
related information or like a performance related information, what do you say, more guides on that would be great, or like even the AI related guides for that, so that we can give the job to the AI to figure out the performance problems and all those things would be great.
yeah, totally correct. So actually, another project internally we are going to work on is give you a stack trace, right? So when you something crash, you want to have a full stack trace. That's something we are working. And for the performance, yeah, we will try to make sure MoonBit, the general code, will be compatible with the PEF tools, the traditional Unix tool based tool. So that's another thing we are going to investigate. Yeah, I think that yeah, that's something we keep on on our radar. Yeah, thank you. Cool. So actually, let me go back to because in the beginning of the meeting, I started using AI to generate code for you. Do you remember, right? Let me check your.
Sorry, my kid was having, she's doing some stand-up, so I joined a bit late, but I'll check the recording.
Okay. No
Yeah.
problem. Yeah. Let me check yeah. Clear. Yeah. In the beginning, I mentioned I made a demo to you. If you remember, I made ask the AI to write a scheme interpreter for me. Then let me check if everything is working correct. Let me check. Uh, if it's work correct, then we can let me with too many windows in I'm on scroll. Let me check to the code system prompt. Mm, sorry, it's not really working. I will investigate why. Oh, okay. Maybe just write it just do the planning. Okay, but my previous experiment giving me all the working code just in one shot. This doesn't happen today. Yeah, I will investigate later. Uh, yeah. Thank you very much for joining me with on a Saturday night.
Yeah,
In fact,
one last comment.
yeah, go
What
ahead.
I say, I think
Yeah.
that what I say, having worked with languages like Rescript to C
Mhm,
and
mhm.
Erlang to Elixir and all those languages, I have to say that in terms of the speed of compilation and what I say, being that true, I think MoonBit might be the first true AI native language that
Thank you.
might be that might be taking off because half of the, I think lately we in the past 6 months I've noticing that I only plan but I really read more code. So in that terms, I think a Moonbit kind of fits the bill quite nicely. So great. Thanks for that. Thanks for this. Thank you very much.
Thank you. Yeah, actually, I'm also very excited about, especially with the latest GPT-5 latest model become more and more knowledgeable about the Moonbeat. So yeah, I'm also very have a very high expectation on how AI will help Moonbeat to grow a vibrant community. Thank you very much. Cool. Does anyone else has any question? All right. Thank you very much for the Saturday night. I will be meeting you guys in a few weeks. Thank you. Have a good day. Let me start here. Bye bye.
Thanks. Bye.
Oh, let me check. There's some other message. Okay. Okay. Cool. All right. Thank you. Have a good day. Yeah. We have a lot of the. Actually, we even give the warning. You know what? Because AI have a lot of illusion. For example, AI we generate. I'm sure one example before we analyze. AI used to generate like this kind of code because this is a perfectly valid Python code, right? Actually, we in Moonbeam, our compiler will accept this code and give you a warning. Oh, do you want blah 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 dot repeat? Yeah, actually, we do a lot of this kind of dirty work to make sure AI friendly. Yeah. All right. Thank you. Have a good day. Bye bye.